So thank you all for coming. I'll continue to let people in as they show up. Today we're doing CodeSmart, Stay Safe, Secure Coding Basics. This is a workshop brought to you by Jerry Jarrett. I hope I pronounced your last name correctly. He's with the Education Pathway National Center. They do a whole bunch of courses on how to create and protect code and personal identifiers and so forth. He will be meeting us again on the interim workshop 1, and that one's going to be a little more focused on your HACC participation solution provision tricks and tips. And the group that he's working with is Ring, or Regions Investing in the Next Generation. So of course you guys are all the next generation. I'm a past generation, unfortunately. Jerry will give you a little more background on himself and his details, but that is kind of what we're doing today, is talking about how to code more securely. And this is meant to be more of a generic, like anything you're going to be doing coding or personal protectors. So I'm going to turn this over to Jerry. He's going to start sharing his screen. I'm going to spotlight him for everybody, so he's out in front. Here we go.
Thank you, Thelma. Hi, everybody. How is everybody doing on a Saturday? You all are in
say something in chat. You can say great, thumbs up, cues.
You all should be great. You are all in the great state of Hawaii, right?
Thank you, Eris. We got a thumbs up from somebody there. Nice work.
Everybody, it's funny. Everybody wants to come to Hawaii, and my understanding is that everybody from Hawaii wants to come to the stateside. It's yeah. All my colleagues from Hawaii, they always tell me like, yeah, we just want to go to the stateside. So, thank you for coming. I understand it's a Saturday morning for you. It's early afternoon. My name is Erik. I am a professor of cybersecurity at the Moraine Valley Community College outside of Chicago, Palos Hills, so just south of the downtown Chicago, about 35 minutes, 40 minutes from Navy Pier and Willis Tower now, no longer Sears Tower, but Willis Tower. I've been teaching cybersecurity for about 12 years now. Before that, I was a security engineer for a few different corporations. And my break, or my way into cybersecurity, or IT, if you will, was through software development. So I actually have a both associate and bachelor degree in software development. So that's essentially how I started my career, right? Then I kind of progressed. They were looking for someone to take over a more security-minded role, so they asked me to get some certifications and eventually master's degree. So I did all of that, and now I'm almost finished with my doctorate in cyber defense. So about all in all, unfortunately, as Thelma was saying, I'm not a spring chicken anymore. So about 27-year career now in IT, with last 15 years being in cybersecurity. Okay, I have some great, I hope, great resources that you will like and we will enjoy. We can engage. I'm not much about PowerPoints. I don't really like PowerPoints. It has its point, right? Its purpose. It kind of keeps me on track sometimes, but I'm really big proponent of a hands-on. I think that for IT, coding, cybersecurity, you name it, nothing really beats the hands-on experience. So today will be kind of a mix of you engaging with me, hopefully, and among yourselves, right? Because I mean, this is a learning experience. You learn not just from me, whatever I can say over here, but from your peers, right? And that's a big component, I think, of education. You all have experiences. You all are digital natives, right? I mean, we all are. I will be honest with you. I'm almost 50 years old, and I will call myself digital natives, right? So everybody who is younger than 50 years old, I think that we are digital natives. We grew up with technology our whole life, right? We are at least users of technology. I'm not saying that we are IT professionals, you shouldn't be at this point probably of your career, but you grew up with and around technology your whole life, right? So we will actually talk about some concepts that are generic, kind of a common sense, I would say. We may not think about them, right? Sometimes we kind of hear them and we think about, oh, here we go again. Someone telling us, to use a strong password or complex passwords and change the password every 90 days, blah blah blah, right? But I mean, there is a reason that these best practices are in place, and we will talk about why and how, and we will talk about some incidents and some cybersecurity hacks that actually were direct results of not following the basic cybersecurity principles, I would say, right, as it pertains to coding, unfortunately, because once again, anything and everything around us, if you think on your daily life, how much of your physical life is now in some way, shape, or form, right, part of the virtual space, right? It's just mind-boggling, And of course, the virtual space, that's all code, right? It's run by some applications, some software, some code, some snippets, right? That will actually ultimately determine how secure or unsecure the data and the interactions between you and the virtual environments are, right? So we will talk about a lot of these things. So let me share the screen, move some stuff around, too many screens here, open the chat. If you want to follow, I just dropped the web page for the interactive into the chat, so you can actually follow along. You can also just, stay with me over here and just follow it on the screen as we go, right? So secure coding, once again, this is interactive. We will do a lot of hands-on, activities today, right? The world's most significant cyber attacks, right, starts with the simple piece of code. Majority of them do, believe it or not, right? There is a myriad of studies that actually says that, make the vast majority, over 80% of all the cybersecurity incidents are directly related to improper coding practices that software developers are actually creating code that they are putting out there that then doesn't really live up to the security expectations that we have, right? Perfect example, the log4j vulnerability about 4 or 5 years ago now. Very small bug, right? It was a common logging library. So think about how code is written these days, right? We use libraries, so we don't have to recreate code that already exists and supposedly, right, works as intended. And perfect example is logging, right? If you are developing your own applications, the chances are that you will probably not develop your own logging mechanism, right? There is enough libraries out there that you can just download and use, kind of off the shelf, if you will, right? That it's almost silly to actually sit down and spend 4 or 5 hours, thinking about how I can develop my own login mechanism, right? And that's exactly what happened over here, So there was the library, right? Everybody was using it, of course, right? And then the attackers found out that there was actually bug in that library that will actually allow them to hack any application that was using the library as a mechanism for validating the identification of the users, right? So, you can see how small, maybe insignificant, you may say, pieces of code can actually take over and wreck millions upon millions of applications, websites, systems around the world, just because there is a small vulnerability, right, that someone exploited over here. So let's start with something fun, right? True story, right? McDonald's, of course, now everything is about AI, and we can, at the end of the lesson, we can kind of think about the AI and where it intersects the security and, the software development, right? I mean, a lot of talk is now about software development and if is it even needed, what the AI will do with it. I don't really want to, make the whole 2 hours all about the AI. AI is a significant piece. We can talk about how, what it does, what it does not, right? What it will be according to me and some of the I do some research about AI, so what the predictions are about the AI and what it will actually do for software developer, right? But the fact is that a lot of companies, they are implementing some AI capabilities into their processes, right? They are kind of re-engineering processes and trying to figure out how the AI actually fits and how it can streamline some of the processes, replace some of the workers, and etc. Right? So McDonald's, of course, multinational corporations, right? A couple $1 million a year business over here. They have this HR systems that the job applicants actually, just essentially apply through the system. The system then it has some AI agent behind it that kind of scan the resume, right? And cut out some of the applicants that were not suitable for the roles for whatever reasons, right? By the way, McDonald's is not the first one or the only company that does it. Majority of them do, and you should know it by now that, I would say vast majority, if not all companies right now, they will do at least one round of HR decision using some automated AI enabled tool now, right? Even if it's just a simple keyword search. So, they will post the job and they will put certain keywords over there. Let's say, certification, you have to have a CompTIA Security Plus certification, right? So there will be some system that actually scans your resume as you upload it when you apply for the job, and it will look for the Security Plus. If is it there, it will put you on the pile, if you will, or in the queue to move on, right? That hey, we should look into this resume, we should look into this candidate. If it doesn't mention the Security Plus, it will automatically put you on the pile of resumes that hey, we don't really need to engage with this applicant, right? Because the applicant doesn't have some of the requirements that we actually ask for, right? So they actually, has this system, it worked. Then over the 64 million people, actually interact with that in different roles, right? Then McDonald, essentially was alerted by a third-party security firm about the security vulnerability that the software developers actually left the backdoor open with the password 123456, right? Which is kind of common practice. If you are testing your system, right, you as a software developer, you usually have what they call backdoors. Backdoors essentially just means that hey, I need to quickly log in anytime I want to see the code, to change the code, to manipulate the code, to do whatever I want on the back end. I don't need complex password for it. I want something simple, something that I will remember, right? Something that doesn't change. The best practice, of course, dictates that you remove it before you put it into production. Clearly, they didn't over here, right? Now, this is a perfect example how, very simple, right? But, almost by default functionality, I would say, if you are a software developer, can lead to incredibly damaging hack here, right? There is the source if you want to read more about it. But I would really like you to take a moment, 2-3 minutes, right? Not much, right? But think about your own experiences, yeah? has any one of you have your online account hacked? Now, social media, email, school accounts, we all have multitude of accounts now that we have to do, that we have to attend, right? Does any of them have ever been hacked? Did you either notice it when you couldn't log in, right? Something happened that you couldn't log in, or that the service provider, let's say Gmail or Yahoo or Facebook, actually send you an email and says, hey, guess what? Your information was exposed because someone hacked our database and now your password is out, right? So some of you, few of you, give me some examples of that. What happened? And you can type it into the chat. That's okay. You can just talk. You don't have to turn on your camera. That's okay, right? But give me some examples from your day.
I'm going to share one.
Okay.
Recently, I couldn't get into my WordPress site. And after a bunch of checking, my WordPress site had been hacked. Over 900 messages about gambling had been sent from my WordPress site. Me not aware of it because I don't keep that. It's not that important of a website, so I don't manage it very well. So one of the add-ons had a vulnerability to it. It wasn't even my password, but they got in, they locked mine out. They had theirs be the active user. And oddly enough, I had to delete all the backups of my system plus a whole bunch of other stuff because we had a hell of a time getting that vulnerability out of the background. So that's my example. We did finally fix it. It took money and back-end support systems and stuff like that. It was a total pain in the ass. Fortunately, I never got black marked because of all the emails that were going out or the postings that had gone out. I apparently caught it in time. They got in again, but this time I was keeping an eye on it. That's why I ended up having to kill all the backups. That's where the vulnerability was. There was something open. So it could have been somebody like this, that there was a code in one of the add-ons that was left open and I didn't know it, and I happened to install it, and the people who are out there doing this kind of stuff knew it was there, and so I was one of the people hacked. So there's my example.
Yeah, that's a great one, right? Once again, it doesn't really have to be your fault. You may just be using a code from other people, right? You may be using services from other people. Anybody remembers the solar wind?
Yes.
Right? What happened in the solar wind? Anybody remembers? Anybody read about it? I mean, it was in the news for months. Right? So there's a company, right, that actually creates a software that virtually every federal agency is using, right? And the company got hacked. The hackers actually got into the company and put backdoor into the source code, and then sent an email from the company to everybody, to all the customers, saying that, hey, there is a new update, you need to download it, install it ASAP. So everybody did, right? Because hey, that's what we are trained to do. Every security professor, everybody ever will tell you, hey, you need to keep up with the updates and upgrades because that's the best practice from security standpoint, right? So all the agencies did it, and like a couple months, I want to say 5-6 months, later, the researchers, they actually found out that the backdoor is there, right? That for 5 months someone had access, right? On-demand access to virtually every agency within the federal government. Yeah. Right? So it doesn't really have to be you. You don't need to do something quote unquote wrong, right? That's why it's so hard to actually get ahead of this problem, right? Because we often think that, hey, I got hacked, I did something wrong over here, right? But it doesn't have to be. I have a personal one, a friend of ours, right? They are older, in their 80s. Their Gmail was actually hacked, right? Now, Gmail is kind of the 300-pound gorilla, right? In the IT industry. So he was using the Chrome to store all his passwords, right?
No.
Now think about it, right? Once again, we tell everybody, and I mean, the cybersecurity professionals, right? We tell you, hey, you have to have a separate accounts for everything, right? Every system should have separate account, all the passwords should be at least X number of characters. They need to be complex, meaning lowercase, uppercase, numbers, special characters, right? All of that, right? Who can remember that? Nobody, right? So, we actually, as an industry, come with the solution and we call them password managers, right? We essentially says, hey, guess what? You will have one password only, and we will then store all the other password behind that one password, right? So every single time when you want to access your online banking, all you need to remember is the one super strong password to get into your password manager, and then in your password manager, there are all the other passwords that are safe, right? But if someone gets the access to the one strong password for that password manager, guess what? The game's over, right? So they stole about $70,000 from his 401k accounts, bank accounts. They opened like 3 or 4 credit cards on his name, right? Moreover, they actually put their own phone number as the multi-factor authentication mechanism to validate all changes to all his accounts. Everybody understands what multi-factor authentication is and how it works? Okay, right? So what happens when I actually put my phone number, to your account? It means that every single time when you change the password, right? The next time when I try to log in, I can just say, hey, I forgot my password. Just send me the OTP, which multi-factor authentication is just one-time password, right? That's OTP, right? And I can log in without knowing the password, but guess what? I can get in and I can see what the password is at that point, right? So even if you change the password, even if I will tell you, hey, you've been hacked, you need to get in and you need to change your password, if you don't change that multi-factor authentication mechanism, if you don't take the phone number out, all your changes, the attackers can see them, right? They can get right around them and they can see every single time when you change it, they can just go in and they can see what the password was, what you change it to, so it doesn't make any difference, right? So for them, the simple fact that they hacked his email led them to tens of thousands of dollars, right? Plus the ability to actually control and have access to the majority of his accounts. Right. Anybody ever had like a social media account stolen, hacked? You guys still do social media? You never know. I'm from the generation that I used to make fun of social media, and now apparently we are the generation that is still on social media when everybody else left. So I don't know, right?
I have a question for you.
Uh-huh.
So I have a password vault that I use.
Mm-hmm.
Is that better than, I mean, obviously they could still be hacked, right?
Yeah.
Yeah.
It's anything that I can design to protect your assets can be hacked.
Okay.
That's the sad thing, right? Now, so what is the trade-off when you have and password vault is just another password manager, right? So you are essentially trusting the company that runs the password vault, right? That they will protect your passwords that are actually stored in that vault, right? Which so here's the kind of catch-22, right? They have the resources to protect the passwords probably better, hopefully better than you do, right? They actually have the teams and they have the know-how about how to protect it, maybe better than you do. They are also much bigger target than you are. Because guess what? I can go after Thelma and I can go after John and Truman and every single one of you guys, right? And it will take me some amount of time, right, to actually social engineer you or hack you to gain access to your accounts, right? Now that's a tedious process, and when I get there, I may get a couple $1,000 from each of you, right? Or I can spend next 2 years to go after the big company that actually stores all of your passwords, let's say Google or Password Vault, right? But when I crack them, guess what? I have access to hundreds of thousands of customers, and I can make millions, right? So it's really about what you want to do, right? You can do the one big score and you can, have hundreds of millions of dollars, or you can just do dibs and drips, and you can get, $10 from 100 million people, right? It's all about the approach that you actually want to do. Alice, that's a great question, right? What is the best way then? So, who thinks that your passwords are secure right now? Just give me a thumbs up or down in the chat in the application. You don't have to do the pool.
Did you see the question from Ellis?
Yeah.
All right. Okay.
We will get to it, Alice. Don't
Okay.
worry.
Just checking.
Yeah, no, yeah, thank you. Okay. You guys are
No, some thumbs up.
right?
Ooh boy, lots of nouns.
Yeah, probably, right? As best as you can while balancing convenience. Okay, that's a good answer, right?
Yeah. Yeah.
So Mike, going to your answer, right? I agree with you. So how would you balance that convenience? What does it mean balancing the convenience to you?
It depends on what you're securing. And if it's something really sensitive, then it should be really inconvenient. But if it is something less valuable to you, then maybe you're okay with a little more convenience and a little less security. So
Perfect, right? So it's all about the value of the asset, right? That's essentially what you're saying. Yeah.
Yep.
Right? If it's in my online banking, I may be a little more careful, right? I may really want to have the strong password, and I may want to use a password that I don't use for everything else. When is it access to my Facebook, or considering that Facebook is not money maker for you, right? I don't know, if you are influencer, that may be different, but social media account, right? I may be just okay. I may just say, hey, guess what? 8 characters, that's okay. If someone will get it, well, such is life, right? But you essentially try to do what we call risk management, right? What is the most valuable thing that you have in the virtual space, right? And then that, of course, should warrant the highest level of protection right? And then it goes down to something that you may not care about, you know, probably not at all, but not as much, let's say, right? And then you can say, well, you know, I'm okay with it, right? I can live with this thing, right? So that's perfect answer. Thank you for that, right? Passwords, for better or worse, are here to stay. Yeah. More and more passwords are moving to what we call the federation, right? So federation essentially just means that one company validates your identity for all the other services. And think, once again, Facebook, Google, right? When you go to some services, it will give you the little button that says login with Google, right? That's essentially federation. You click on it, it will take you to the Google services. You put Google username and the password for your Google account, right? Once Google actually validates you as a user, it will send the information back, not the password and the username. It will just simply send the check that the validation was successful back to the original service, and the original service will then allow you to use it, right, in any way, shape, or form that you want. If you use a Spotify or services like that, I mean, that's very prevalent for them to actually use a third-party authenticator like that, right? So, you know, we are moving away from memorizing all the passwords, you know, to put them in some single systems, right? It used to be single sign-on, and now it's more the federation system that I just described, right? I will still be very careful, and you need to perform some kind of risk assessment on all of your online presence, right? And kind of decide what is the value of every single asset that you have out there, right? And how much is it worth? And how much effort, time, sometimes even money you want to spend to protect it, right? It's really no different than your physical assets if you think about it. You know, you probably are more careful if you will, you know, drive a nice BMW than if you are, you know, riding a bike on the street, right? So that's essentially the same thing. Not necessarily, Alice, right? So everybody understands how biometrics work. What is biometric, by the way? And we can come here. Oops. It's my image. So there's a great, this is some educational materials that my team actually created. Biometrics is right here. I don't even have to click on that. And I can give you access to this. But so biometrics, right? It's the calculation of some unique physical characteristics, nothing else. You know, nobody is saving your physical fingerprint or your face, your picture of your face, right? It's mathematical calculation that actually depict the, you know, differences between the center of your eyes and your nose and your mouth, right, on your face. You know, how tall your forehead is. You know, on your fingerprint, it looks for some of the ridges, and once again calculates the distances when you actually press the finger, right? That's actually how it works. You know, you have psychological, right? Iris, fingerprints, face recognition, all of those that actually make you who you are as a person. You also have behavioral, right? So nowadays they can actually compute with great certainty, right, who the person is by how you walk, right? So the gait recognition, you know, what your step look like, right? What your movement looks like, you know, your voice, of course, you know, they can do amazing things, but the keystroke, you know, how quick you are to hit the keys, you know, with what force you hit it, what are the delays between the strokes on the keyboard. It's all has well over 90% accuracy now already, right? I mean it's so good that we can literally make the decision about who the person is based of those behavioral characteristics now, right? But you know, there is the mission over here. So just so you know, this is a facial recognition. So you can see how it actually just picks up the points on anybody's face, right? And then it computes it and it stores it as a hash. So it is essentially the same, just like if I will create a password, right? The password is hash, you know, the hash is then stored, right? This is exactly the same thing. If I understand the points and the difference between the points, you know, I can just send it to the system. The system may not even care if the face is in front of it or not, right? All what the system cares about is the difference in these points here. You know, if as an attacker I understand what the points are and what the spatial difference is between those points, that's all what matters here. Yeah. Right, retina scanner, the same, right? I mean, it just takes the picture of your eye, looks for those veins, and you know, so is it better, worse? I would say, you know, it's the same, right? It's once again just kind of depends on how secure the password is and what the protection is for those hashes that we actually store. Okay, that's a great question. A lot of my students thinks that, hey, you know, just because I don't use passwords now, I just use biometrics. That's inherently more secure, right? And I would say that that's false statement at this point. So great question, Alice. Right. So I want you to think about it, right? Security. Is there a system that is 100%? In other words, can you actually code something as a software developer that will be 100% secure? What do you guys think? No? Okay. Perfect, right? If you don't remember anything else from today, I want you to remember that, right? There is no such thing as 100% security. It's just kind of defeatist, I understand it, but it also means that it's a job security for every single one of us, right? That's how I'm looking at it. If there is no risk, right? If I can actually design something that is 100% secure, there is no need for cybersecurity. There is no need for us as a professionals, yeah, because everybody will do it, right? I mean, if I know what to do, if I have the silver bullet, so to speak, to actually design something, why wouldn't I do it, right? So there is no such thing, right? So it's lesson number one. I have a little email over here about the basic programming concepts, right? So this is after all about programming. So if you want to know something about the different vocabulary as you are, as you are going into your software development career, I strongly urge you to actually learn all of these, right? IT, just like any other field right now, has its own almost language, right? There is so many acronyms, so many words that you need to understand to have smart, right, conversation with other people, Once again, there is kind of a lot of talk about the AI, and the AI will do all the coding. Guess what? If you don't understand any of these terms, right? How would you even ask the system to do something for you, even if the system is actually able to do it, right? So you have to understand the vocabulary, the both, understand what your customers are asking you to do, right? What they actually want from you. So that's reason number one. And the second, of course, if you want to use agentic AI to actually code for you, right? Or wipe AI, whatever you want to call it. People use it interchangeably right now. You will have to provide that context to that AI to actually write you at least a basic code, right? So there's all kind of different terms that we should go over, right? What are the data types?
Integer.
Right.
2.
So just data type
2.2. String.
and what they actually need, right? As you are moving through, the system needs to know what data it can accept and why, right? From the security standpoint, if you think about it, and we will talk about data validation, if you don't tell the system what data types it can expect from the users, then you cannot really enforce data validation, right? So it's incredibly important, both for coding, right, but also for the cybersecurity, for the security of your code. Variable,
Equal
right?
bool.
How big, what is the value that is actually in the word that you assign to it, right? In the box, if you will. Statements,
Balls move
right?
equals balls and move.
So that is actually some type of movement, right? Some action that happens with the data.
Function add balls, red, blue.
Function,
Return
then
red plus blue.
routine, something that you do over and over and over. You can do that once, right? You have to do it at least once. There is no reason to have function that you don't perform, so you have to do it at least once, but most likely you will do it multiple times through your code.
Ball 3, 5.
Arguments, right? Putting the balls together. Arrays.
Red balls.
We have
three, blue
multiple
balls,
data
three.
points nowadays that we work with. Kind of the old days of thinking about programming 1 + 1 = 2. Who cares anymore? I mean, there is, once again, there are libraries that will do simple multiplication or addition or subtraction for you. You don't really need the code for it, right? The arrays is what the modern computing is all about, right?
If red ball rolls, else if blue ball bounces, else green ball flies.
Decision structures, that's essentially the meat and potatoes, right? What will happen depending on the data, depending on the input from the user, output from the systems, what is the final result here, right? That's what the decision structures are providing for you.
While red ball.
And then, of course, the loops, right? And the loops are essentially you performing some actions until some predetermined value hits, right? So you think about it, you can withdraw the money, all the way until the account hits 0, right? You can come and you can say, hey, I will, I have $1,000, right? I want to withdraw 500. It will check it and it will says, okay, here is 500. The new balance is 500, right? I'm waiting for your new instruction. Well, I want to withdraw another 400. Okay, it will check it. It will give you 400. It will says that the balance is 400. You want to withdraw another 200 and it will tell you, hey, I cannot give it to you, right? Because you don't have 200 anymore over here. So the loop will go through all the way until it will essentially says that you will be at 0 or below 0 value over there, right? And we use loops all the time. in a structured programming, right? So these are some of the basic things that you don't need to get familiar with, that you have to understand, right? And you have to really start thinking about not only how to implement them, how to make them actually perform the function that you want from that, right? But also how to secure them, right? How to make sure that someone else cannot abuse any of those concepts, right? And the perfect example is the loops, right? You have to make sure that nobody can really override the loop that says that, hey, you cannot go below 0 on your account over here. And they will try, right? I mean, that's what attackers do. That's how you can exploit some of the systems. If you actually send some kind of statement that the system cannot process and then behaves in ways that you as a software developer didn't intend it over here. Okay, so basics of programming. So let's get to the secure coding. We kind of already play with this, right? So there is a password strength simulator. There is a tons of these tools online. When you can actually put your password, you can show it, right? So any of those, will be of course weak, right? Then as you are putting special characters here and numbers, they will become increasingly better here, right? The discussion, the best practices for strong passwords, length is the king, right? So right now, it used to be 6. Actually in my career, in my almost 30-year career in IT, believe it or not, we started with 5 characters, right? I still remember when 5 characters was actually considered strong password, right? Then they increased to 6. Then it increased to 8. Now, for the general population, the best recommendation is actually 12. For DoD, the minimum now is 18. So if you actually work for the DoD, your minimum length requirement according to the NIST framework is actually 18 characters, right? Why? It's increasingly harder to crack, right? The more characters you have, you exponentially increase the number of possibilities that someone has to go through if they want to brute force it. What is brute forcing it? Anybody knows? When I say brute force your password, what do I mean by that?
It would mean to go through every single combination until you find the correct one.
Precisely, right? That essentially means that, hey, I will send every possible combination, right? So think about it, 26 characters, right? In the alphabet. So every single character I put behind, even if it's just lower case, right? I'm exponentially increasing it, right? I'm essentially raising it by the 27th power. So the length is always the king here, right? The longer it is, the more secure by default, even if you don't do any complexity to it, right? Then the complexity comes from mixing it up, right? Uppercase, lowercase, numbers, special characters, right? That's always the 4. Some companies, they will tell you how many of which you have to have. Some systems, they will tell you have to have at least 2 numbers, you have to have at least 2 special characters, whatever it may be, right? But you have to mix it up, right? When you put the length and the complexity together, you'll be in pretty good shape, right? There are still downfalls, but you will be in pretty good shape, right? One of the downfalls is password masks, right? Typical password will be something like this. Why? Why do you think that this is a typical mask? Anybody want to take a wild guess? It starts with a uppercase. Why? Because that's how our sentences are starting, right? Every sentence that you have ever seen as a human being starts with the capital letter, right? It's just natural to us. Then we put bunch of lowercase characters, right? And then guess what? Someone told us that we have to have a one number and one special character, so we put it at the end. You know, kind of, tuck it very nicely at the end, right? It's human nature, yeah. There is research after research. There is a company that actually does that analyzes, password hacks when someone steals passwords from a Google or a Yahoo or something. They will usually go through it and they will, try to figure out what are the most popular passwords for the past 15 years. This is the pattern, right? Because this is how we as humans think about sentences, right? Starts with the uppercase, lowercase characters, and then whatever is there, we put it at the very end. Yeah. If we are really inventive, I can come here and I can change the I to one, right? I saw that, ours is sometimes force, right? Something that, resembles that, right? Everybody knows that. The attackers, they know it, right? If I know that this is the mask for your password, just think about how much it cuts down on the possibilities that I have to do if I want to brute force you. Yeah. There is a research that says that if the company or if the system requires at least 8 characters right now, which majority of them do, about 8, right? Over 95% of the users will do exactly 8, not 9, not 10, right? They will hit 8 precisely, and that's it. Right? So just think about it. I already know that it will be 8 characters long. I know that the first character will be uppercase, right? And I know that the last 2 will be either a number or the special character. I just cut down the possible choices tremendously. So you have to be careful about it, right? Once again, length is the king, complexity is given and usually enforced. Let's face it. Majority of the systems now out there will actually require you to put at least one uppercase, one lowercase, one number, and one special character. So that's kind of given, right? You cannot really select a password that doesn't have that complexity for that, right? But you have to be careful about predictability over here, right? Uniqueness is crucial, yeah, and we can talk about it, and we kind of did already, right? How often we reuse the passwords, yeah, how we actually change the passwords sometimes, right? So if this is my password, once again, right, and I'm asking you to actually change it to something else, what will majority of the people do? What do you think? Don't overthink it. It's all good. This, yeah, right? Not just change one character, they will change the number, right? Once again, that's the easiest thing to do. Guess what? I already remember this. I'm not forgetting this and learning something else, right? All I need to do is to change the last number. You will actually have people who will go and literally do this every single time, right? Just change the number, append, put it to the end. So append the number to it and change it. That's what we do as a humans. Yeah. Right. Be careful about it, right? Once I know that you do this, my next guess is that I will go and I will just, and if I would figure out that this password is not working, but I know that you used it before, I will do this, right? And I will do this, and I will do that. And if that doesn't work, I will do this, right? I will just assume that you just append another number over there, because majority of people, that's how they will approach it, right? We have to be careful about it, right? The best way to do that, there is a couple of mnemonic devices. I really like this. Have some phrase, right, that you remember. Hey, June is my favorite month for the whole year, right? You look at this and you can say, well, I will replace F's with, let's say, 8s, whatever it may be, right? I will change the I, the exclamation point, excellent password, right? And you just remember that phrase. And of course, then you have to remember what you change in that phrase. Right? I mean, that's one of the ways how you can actually do that. Right? People don't do it. Yeah. Once again, I told you about the studies, and there is one of them. Essentially, every year, it happens like a clockwork. Unfortunately, that there is a big dump of passwords, right? That someone hacks the big providers, usually because multiple users are actually unsecure, so they get through the users to the companies itself. 184 million Google and Apple passwords were leaked this year, actually, in a spring. The last year, 2024, I saw the statistics like 6.4 billion passwords were actually leaked online. So just think about it. If I have that information, I can infer, right, with great certainty, actually, about what your next password is, or what the most likely password that you can select will be when even if you change it, right? Because I can literally just run the statistical analysis and find out what the mask is. What are the chances that the first letter is capitalized? What are the chances that it will be 8-character long? What are the chances that there will be exactly one number, exactly one special character? All of that is essentially known from that point on, right? So you have to be careful, right? So that's just for the passwords. If you want to know more about the passwords and how they are actually created, right? And we kind of talk about it when Elise asked about the biometrics. Thank you for that question again. Then you can actually go. There is the hashing, and that just goes through
in cryptography,
how hashing actually happens, right? One-way function. You actually put all the information and it creates what we call fingerprint of the data, right? So you cannot actually get back to the original data, and that's not the point to get the original data. You actually want to know what that mathematical representation of the data is after you run it through some algorithm, right? It runs on mathematical formulas, of course, over here, so you can go through it to see how it actually gets to the binary state, right? From the binary state, it actually goes and grinds it, put it through some algorithm, and it actually comes up with the value that then will represent the password as a ABCD, right? So the computer actually stores this, right? Every single time when you put the ABCD, it will run through the same process. And as long as this number is the same, it will validate you as the user, right? It will actually say that the password is correct. if is it anything but this value, then of course the password is incorrect, right? So that's all there is to it. The password protection, right? It's essentially simple hash. Once again, the system doesn't necessarily care about the ABCD. It doesn't care about your face, about your fingerprint. All what it cares about, if it runs the data through the hashing algorithm, what is the value that it's getting out of that hashing algorithm. Okay, that's how it works. All right, now the fun is about to start, right? I talked for about an hour. I know that you are tired of my voice. I know that I'm tired of my voice. So let's have some fun over here. I want you to try to actually fix this code, right? And this is a pseudocode. It's not the full snip of the code here. You have some hints over here, 3 hints that will actually hopefully lead you through it, right? There's only about 4 lines of code that you kind of need to add to it, right? You can put it over here. You can check the code. I would like you to, we will split, how many people do we have? 17. So let's do
So that's counting you, me, and my uh, recorder. So we actually have 14.
14. 14. That's perfect. Let's do 3 groups of, well, 2 of 5 and 1 of 4, right? I will put you in the, stop sharing real quick. I'll put you in a breakout rooms. I want you to think about it, right? Don't sweat it, don't overthink it, right? Do some basic research. You have a Google, yeah. Do some basic research, use the hints, right? And try to figure out how you will actually secure that snippet of the code over there for now. Okay. And we will give it about, let's give it 10 minutes or so. And then we can come back, we can talk about it. We will actually write it, verify that it works, and we can move on. How about that?
Sounds good.
Okay. So 3 of them, I will open them right now. And I will kind of jump between 2 rooms, so if you have questions, you can ask some questions. But I really want to hear some discussion between you. And once again, you can just type it over there. I don't care, right? But you don't need to think about it, discuss it. This is a team building exercise, if you will, right? About how you will actually improve it. Sounds good? All right, I'm opening it right now. Hey, they were all listening because they all jump.
Nice of you to take care of the breakout rooms.
Oh, no worries.
I'm gonna pause them.
All right. So what did we figure out, guys? So what is the problem here?
The problem is storing the password in plain text into the database.
Perfect. Right here, right? So what this does, it's essentially you are assigning value to some variables, right? So it's constant, that's the variable, right? For the user, username is username and password is a password, right? So this is exactly how it will actually pass the information to the database. So what can you do about it? It says in the hint 2 over here, right, that you can do something that they call a function over here. For the password, right? So what I can do over here, I can add salt to the password. What is salt?
Salt is a random string to help like prevent passwords that are, I guess, coincidentally used the same by other users to produce the same hashing output.
Perfect. And not coincidentally, but it essentially makes the password stronger, right? It adds the characters. We talk about it, length is a king, right? So it adds it, and it makes it more complex from that point, right? So that's all you need. So we can just say, hey, we will add salt here, the password, right? And we will say that the new constant, and we will call it salted pass equals the whatever password, right, that we have here, plus the salt, right? In real world, the salt will be provided, right? There is actually a mathematical function that is available to you as a software developer that you can just invoke. You can also just create a salt. You can literally, I can put over here on the top, and I can say that we will create salt, and I can say that once again constant salt, and assign some value to it, right? And let's say it will be A, B, C, D, 1, 2, 3, 4. Yeah, why not? Right? So this will be, of course, this is a bad practice, right? Because now the salt is given once again. It doesn't change. The automated algorithm that actually exists will, generate a new salt, unique salt every single time when you want to add it, right? When you want to append that, right? And then, I will do just what? I will hash the salted password, right? That's the last step, right? Over here, you actually have to you have to hash it, so it's not, it doesn't show like this, right? It actually shows just the hash that we talked about before. And then once again, it will be just constant, and it will be hashed fast, right? And the hash password will be, the hashing algorithm over here, and we will put the salted password, which is what we created right here, right? And the hash is just the hashing algorithm. It can be a bcrypt or whatever you want that will actually work here, right? And you can see that, it was implemented, right? So you just essentially took this, right? When anybody can just see that the username is username and the password is password, right? Even if someone will actually select the username as a username and select the password as a password, right? Now it will actually, the password will actually be password ABCD1234, right? Because we are adding it right here. And on top of that, it will actually be salted over, it will be actually hashed over here, right? So it will be actually run through, and then instead of just seeing password ABCD1234, they will see, XYZ, whatever, some random numbers, random characters that will actually mean absolutely nothing, right? And because it's one-way function, there is no way for anybody to take that salt and actually decode it, right? There is no such thing as a decoding, right? So this is just simple exercise how you need to start thinking as a software developer about how you will actually protect the data, right? This is for password, for username and passwords, because that's kind of the poster child of the whole security, the secure coding movement. But if you think about PIIs, right? What is a PII? Anybody knows what PII is?
Personal identifiable information, is it's something like that.
Yep, perfect. Personally identifiable information, right? Essentially, your social security number, your driver's license, all of that I can actually, there may be 15 Alice, Natalie Alice's, right? On the planet, I don't know, right? But your social security directly identifies you, uniquely identifies you, right? So that's essentially something that you really want to protect if you are developing some applications that will actually deal with social security numbers, with passport or driver's license number, with a frequent flyer numbers. I mean, all of the unique identifiers for a people, then you really need to start thinking about how you will protect it, and you protect it by hashing it, right? And of course, the video, on the hashing best practices, it's over here. And yes, Natalie, it's 100%, it should be random, right? It should never be fixed. Now, once again, this is kind of, we just put it over here to like demonstrate where you will actually get the salt from over here. But in real world, you would never, hard code your salt in. Right? You will use a library that will actually run mathematical formula and come up with a unique, distinct salt every single time when you want to add it to the password. So that's excellent question. You have to simplify it a little bit for learning purposes, right? All right. So let's do another one, right? So Microsoft Team vulnerability, August 25. This is actually so fresh that there is only a few articles about it. The source is here if you want to read more about it, right? We talk about the need for hashing of the information, right? Another good practice for the secure coding is actually what we call the input validation, right? Input validation essentially means that someone will try to input some data that the system didn't expect, and then the system will behave unpredictably, right? Perfect example. Years ago, actually decades ago now, there was a fundamental flaw with the ATM machines, the automated teller machines where you get cash. I don't know if you guys still do that. If anybody actually go to ATM to get some cash here and there. But the first ATM machines, the data type was set incorrectly, right? It was actually set as an integer. An integer essentially means that there is some upper boundary, right? It's like 185 million or whatever, right? But essentially what the vulnerability was that if you actually put a higher value than what the integer can accommodate, instead of subtracting the number from your account, it will add it to it, right? So people will essentially come and they will say, hey, give me so much money, that instead of giving them the money, it will actually say, hey, you just deposit all that money into your account, right? So the system was, cheating the bank, if you will, right? Giving too much money to the users, right? And that was a perfect example of improper input validation, right? Should it be coded properly? The coder, the software developer, should really says, hey, if the number is outside of this boundary, right, nobody will ever come to the ATM and ask for $100 million, right? So if is it more than, let's say 50,000, I don't know what the upper limit is, but some reasonable upper limit, right? Then just output error message saying that, hey, you cannot get that much money, there is most likely error, right? Try again or whatever. Yeah. So that's how input validation essentially works, right? So if you look on this code, right, the flaw is here, right? Why? Anybody can tell me what is the security flaw in this code? Is the function too long, right? This is the function, right? Save the profile to database, and it saves the user profile. That's the function, right? Is it too long? Is the variable name, the new bio, new website, not descriptive enough? So you have the bio, new bio, website, new website. Is there no input validation on them before they are used, right? Or is the user profile object not in a class instance or a simple object? What do you guys think? Perfect. See, right? There is no input validation. Guess what? This is the user profile. Whatever I put here, it will essentially take it as a profile, right? And try to push it into the database as a user profile here, right? And then it just outputs the message. You know, the message is just an afterthought. You know, it doesn't really have any purpose over here, right? In the code for our purposes when we talk about security here, right? So how would you fix this now? What needs to happen over here? How would you actually force some kind of validation? Well, we just talked about it, right? So we can say that the bio needs to be certain length, right? That's one way to do that. So bio can only be certain length, right? And this is simple if then else statement. If new bio, right? So this is it. We are talking about this. That will be assigned to the bio variable, right? If new bio and its length let's say is more than what should we say? 300 characters, maybe, right? Then perform something, right? And we will say throw error here, or new error because we actually didn't have the error yet. Right? This is all what this does is say check the new bio, right? And if the length of the new bio is over 300 characters, error, you have to spell it properly, then essentially just show the user the error and says bio is too long, please make sure it's only 300 characters. Right? So now guess what? Nobody can push, 1,000 pages, 6 million characters into that space. The system now knows that the maximum length is 300, anything above 300, just throw the error for me, and let the user know, right? If the users do that over and over, we can even say that, hey, after 3 tries, just lock the user out and, prevent them from doing it again, right? You want to stop the loop somehow, right? And, if we can do that for the new bio, we can actually limit the data types, not just how many characters, but we can limit the data types. So we can say that website must be an URL, right? So we can say, hey, we don't want you to input something that doesn't actually fit the profile, right? So it has to start with something. We can also say that, hey, it has to have certain mask. Let's say that you want social security numbers, right? So it's a what 10-digit number, right? It's a 3, 3, and 4 numbers. You know, we can do that with phone numbers, the same thing. You know, we can do that with the driver's license numbers. If you know what the mask for it is, you know how many characters is in each of them, you can just limit the number of characters. You can say, hey, this can be only numerical value. You know, there is no social security that actually has characters, right? So it's all numbers. So if someone will try to put a somewhere or B, you know, or special characters like equal sign or any of that, you know, we can actually prevent them from that, right? But we can just do something simple. Hey, it has to be URL. How do we do that? Well, if new site and new website starts with, and we will just say HTTPS, right? Because we really want the be HTTPS code here, right? So all what this does, this is actually one word, right? All what this does is looks for the new website, right? And make sure that the new website starts with HTTPS. This exclamation means if it doesn't, right? This is opposite of yes. So does it start with HTTPS, right? If it does, just let it go. If it doesn't, then once again, you know, we will just say throw new error, not a valid website. Right? And this is just the error that they will get, right? If this is not true, this signifies that this is not true, right? Then just do that. That's okay, Tyler. Thank you for coming, right? So now you can see that I, you know, did 2 input validations over here. One was kind of generic over here, right? I just said that the length can be only 300 characters. If it's more, hey, you know, you really need to cut down some of the stuff that you put in there, right? But I can also do the data types much more, you know, nuance, I would say, right? That you can actually play with here. I can close this. I can close that. And we have probably spelling. Length is misspelled. It's not good if you cannot spell. That's why I like spell checkers. Websites starts with. Oh, you gotta be kidding me. Websites and it's much better if you just did this. Yeah, I just copied it from. I actually have it over here, right? But it's the same thing, just not misspellings like I did before. Right? What it starts with, right over here, and then the length on the top that we have, right? So input validation, incredibly important. You know, people will try to inject data into your applications, right? Both data and actually harmful code. You can inject code actually I can do something like a script that I can try to push on your application, and then if the application will accept it, then I can execute the code on the back end, once the application actually accepts it. Secure coding, and we are kind of running out of time, but I have a couple of different examples over here that you guys can play with, right? The whole point over here, these are all fairly recent 2025 examples of unsecure coding practices and the damages that they actually cause, right? So just read through it, right? Kind of uncover what happened during the breach here, what was the cause, right? So what coding choices do you think, that actually made it possible? So what mistakes the software developers did, what best practices they did not follow, if you will, right? And what they should do instead of it, right? So based off of the knowledge that you now have about the secure coding practices, what will be some of the best practices that they really should follow, right? And they are all, if you look at them, they're kind of scary. I will be honest with you, So farmers insurance data breach over here, right? What was the damages? You can see, 1 million individuals, right? That's a big number, right? I mean, that's a big fine. It cost the company a lot of money if you think about it, right? In what they do. The Allianz Life over here, right? Once again, hello all, right? All about the weakest link. Once again, 1.4 million customers. Just think about it. Once you have over 1 million customers, that's a huge deal for them, right? But they essentially, use the social engineering, right? Simple posing as a IT help desk staff, and then they essentially download all the PIIs that we just talked about, right? So, FBI got involved, Secret Service got involved, right? The company is in, hot water still to this day. TransUnion, right? 4.5 million customers, right? Had the sensitive data exposed to it, right? And by the way, the sad thing is that these numbers, they are kind of preliminary. You can see that this is actually July 28. They are still, to this day, doing the after action reports. I would say that this number will at least double, if not more, right?
Yeah.
It's all. Go ahead.
I just said yikes.
Yeah, it is, right? That's just how it works, right? The first, the preliminary is kind of, that's the most visible thing, right? And then you start digging in and you start actually uncovering what truly happens. And the good rule of thumb is that it will double two and a half times as many customers and about doubling on the damages. So just think about it. If they are talking about 4.5 million, that means about what? 11 million customers exposed, right? And then if the damages are $100 million, so then it's essentially double. It will cost 200 million to actually clean up the mess that this thing cost, right? Connex Credit Union over here, and you can see that a lot of those, they are going after what? Insurance companies, right? Financial institutions. And we talk about it, you go where the money is, right? Now, unfortunately, a lot of these attacks, they are victims, I would say hacking industry, there is actually, believe it or not, there are certain countries on this planet when people will go to work just like you and me go to work every day and work on, for Walmart or Dairy Queen or McDonald's, and they will try to hack other corporations, right? That's how they make money, it's enterprises just like once again, just like office work here in the US. They will work 8 to 5 and they just, they go home after the shift and they don't even think about it, right? I mean, this is essentially what they do. That's how they can make money. That's, they will get paid well for what they do. So that's essentially what they chose and what they select, right? Teamster Union over here, health services and insurance plans, once again, PHIs, right? So now we are moving from the personally identifiable information to personal health information. Big business about personal health information. You can cause a lot of damages if you know, right, what health issues people have, right? So now if you think about it, how much we digitalize, the health information, how much, once again, of the physical world we live in that virtual space that I talked about at the beginning of the lesson, uh, if I know what health issues you have, right, and I want to sell you health insurance, or I want to sell you a life insurance, right, or even I want to hire you, right, I can just check your history and I can say, hey, you will cost me too much money in my health insurance because you have all these health problems. I'm not going to hire you. I'm not going to underwrite this, right? I may not give you 30-year mortgage because I don't think that you will be alive for that long, right? I mean, it has a far-reaching implications, when we start talking about all of those personal health informations that are actually available. Hospital over here, you can see 16 months, right? So it took them 16 months to actually do the after-action review to figure out what happened, and now they are actually telling the customers that, hey, yeah, by the way, someone had access to your data for amount of time. We don't even know how long, right? And it was essentially a year and a half ago now, right? So, these things, they are far-reaching, they are persistent, right? They are going on for a long time, and they are essentially just, once again, the sad thing is that they are all caused by improper coding techniques, right? Flaws in the code that really should be designed better, right, and test better before putting in production. And then the Computer Metrics USA, another, I find you are a human. I am human. Right? 318,000 people, right? Ransomware, another ransomware attacks, and once again, medical technologies, right? So they just like before, they are going after those PHIs, and now after the automated systems in the hospitals, right? There was it was actually years ago now, about 5 years ago in 2020, there was a big cyber hack of the hospital in Great Britain, in the UK, when they essentially have to airlift patients to other hospitals because their systems were taking in a ransomware, so they didn't even know what medications the patients need. They didn't know what they gave them, what they should give them in the next round. They couldn't perform surgeries. I mean, they were essentially completely blind, and they call, I would say, 55 helicopters from like a British Army to actually airlift the most serious critical patients from the hospital to the other hospital because they were unable to perform even the basic tasks on them. So just think about how disruptive and that is. Right. So that, once again, you can kind of do that on your own. I think it's a good exercise, to actually see what the causes are, right? To identify the causes and then kind of think about what will be some of the best practices that could have overcome, right? Or even mitigate, even if you cannot stop it, right? we are talking about 1.4 million customers. If is it 100,000 customers versus 1.4 million, I mean, that's a win in my book, right? So, maybe we cannot prevent all of it, right? But we can minimize it, and we should strive to minimize it. And then finally, this is the last slide that I have for you today, guys. So what are some of the secure coding best practices that we have, right? We talk about them. Never trust the user input, right? And we just talk about it. You need to make sure that you sanitize anything and everything that your application will actually accept before you pass it to your data storage, right? So the database, it needs to be sanitized. You need to verify that whatever you are actually putting into the database, into your data storage, is the data that you expect that you want over there, right? Probably the most critical step if you are talking about data transfer is the sanitization. If you don't know what data the users can send, and I'm not saying that all of it is malicious, right? But just think about it. Sometimes people make mistakes. Sometimes it's unclear, right? Even simple things like if your application want to process the addresses, right? And you are talking about states within the US, are you allowing the people to type in Hawaii versus HI, right? Kentucky versus KY, right? Now your database can have both of them, but it's kind of a mess, right? Half of your customers will do HI, half of them will do Hawaii, half of them will misspell Hawaii, so there can be all kind of variation of that, right? So how do you sanitize it? How do you actually validate it? Then if you want to use the data, of course, you may run the query and you can say, hey, give me all the customers that put the state as a Hawaii, but what if someone misspell it, right? What if someone put a HI instead of Hawaii? So you really have to think about all of these, right? And you can never trust the user over here, right? Use the hashing passwords. We spent a lot of time today talking about the passwords. They have to be hashed, so they are not in a plain text, right? Bcrypt, Argon, both widely available for you in every programming language, so wherever you code in a Python, Java, VB, or any other language, they all have the libraries that will actually allow you just to implement the hashing algorithms, so you don't have to design it from the scratch, right? But that actually is the defense that you need to implement for sure. Principle of least privilege, we didn't really talk about it, but it's critical that you limit the permissions on your system. That kind of goes without saying, but once again, it's kind of the time and true, right, tested principle that you really need to live by. The limit the access to people that need the access is crucial, right? So you really need to make sure that only admins of the databases of the systems have the administrative privileges. Everybody else is kind of, on the different playing field, if you will. Keep everything updated. We talk about updates, right? Kind of a catch-22 sometimes here and there, right? You have to be careful about the updates, where the updates come from, right? Who is actually pushing the updates, right? And why? The best practice is to test the updates before you put it into production environment. So you download it, you put it in the testing environment, you play with it, you make sure that it's actually safe before you push it to the production, right? Once you push it to the production, of course, if something's wrong, well, the game is kind of over for you, right? So you never rush the updates and upgrades to the systems. You also don't just not do that, right? Because there is a tons of updates, upgrades. The update policy should be fundamental to how the enterprise actually operates. There should be clear checks and balances about how often you will check for updates, who will test them, who will put them in a production, and what people need to sign off on the pushing the updates to the production environment. That's all part of the good governance, right? And the last one is you really need to start thinking like an attacker, right? At least to some degree. You know, you don't have to be penetration tester, you don't have to be hacker necessarily, but you really need to start asking yourself, if I would want to, right, how would I go about breaking my application or my code? You know, what would I do to actually overcome some of the security features that I'm putting in place over here, right? And if I do that, what is the worst case scenario, right? Is it that the application stops working? Is it that my application starts leaking personal information of my customers? Is it that they will start stealing money from me as a company? What is the worst case scenario, right? And start really thinking about that whole risk management process. What is the most damaging scenario and how I can prevent it or at least minimize it as much as possible here? Okay, so that's the top 5 that I will say are absolutely critical. You know, starts with the user input, but going down to the line of what you really need to start thinking about as you are developing your apps. All right, guys. Thank you so much. I hope that you enjoy at least some of this. I understand that maybe the coding was a little over your head, right? I just want you to understand the basic principles. I mean, the code was there is much more to it than just sanitize the input, right? Make sure that someone actually puts a 300 character or whatever bio. I just want you to start thinking about all of these best practices as you are embarking on your journey to actually start developing some code and thinking about the applicability of that code in the real world, right? Not just for you for fun, but how do I make it commercially viable without opening myself and my customer and the society to some great damages over here? Okay. Any questions, comments? Thank
I
you,
have a
Nat.
question for you.
Okay.
The links that you provided on the interactive and the biometrics, can I share those with everybody on the website when I share the recording?
Of course. Yeah. That's a public, public domain. Yeah.
Okay, thank you.
Yep, you're welcome. Thank you,
Well,
guys.
I want to say thank you for this great workshop and your time today, and we look forward to your next presentation. Everybody who will be, lots of thank yous. Thank you for engaging. Insightful learning experience helped me greatly. Nice. Thank you, Luke. And was great job. We have another workshop that Jerry will be teaching. The first interim workshop, the security, or no, I'm sorry, it'll be the second. Let me just double check where I have you working. Yes, I'm sorry, Jerry. You're on November. You're on November 8th, not October. So you're the second one. So Jerry will be with us again on November 8th. Again at 9. He's the 9:30 session. Securing apps and protecting privacy will be that one. It'll be a similar type of thing, but it'll be more geared towards the event itself and steps you guys can remember. There's a 300 word question for when you're submitting your application of how would you secure this this code. And I think there was a lot of good information today, and that'll be more the focus of the next one. So looking forward to that. I think that this was a little different than we've had in the past, and it was an excellent presentation. I really like the interactive part, and we'll be sharing that link on the website once I get the recording all tweaked and so forth. Thank you, Jerry, for Mr. Jarek. Some people were calling you Mr. Jarek. Thank you so much for your time today.
Thank you, guys. I will try to prepare something interactive for the November 2. I really like it. I hope that you guys enjoy it, and I think it's much more engaging than just reading something from PowerPoint. So,
Agreed.
thank you.
All right. Thank you, everybody.
Thanks, guys. Enjoy the beautiful weather in Hawaii.